Hi, Mr. Richards here, and today's lesson is on slope-intercept form. Our objectives are to determine slopes and y-intercepts of lines and to graph linear equations using the slope and y-intercept. As we can see in our key concept box, our key concept is slope-intercept form. Now, in words, the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So in our equation, y equals 2x plus 1. The 2 is in the spot of our m, so that is our slope, and the 1 is in the spot of the b, so that is our y-intercept. And remember, the y-intercept is where our line crosses the y-axis. So, when we are asked to state the slope and y-intercept of the graph of the equation, y equals 1/2 x plus 3. This 1/2 is our slope. It is in the spot of the m. And this 3, that is our y-intercept. It is in the spot of the b. Now, in this question, it was a plus 3, so it's a positive 3 for our y-intercept. So if we were just to rewrite this out just to make sure, our slope in this question is 1/2. Our y-intercept is 3. State the slope and y-intercept of the graph of the equation negative 4x plus y equals negative 10. Well, this example looks just a little bit different than the last example we just did. Well, we need to make it look exactly like the last example we just did. We want to get this into the slope-intercept form of y equals mx plus b. In order to do that, we need to move this negative 4x over to the other side of the equation so we can get our y alone. Well, if we add 4x to both sides, this negative 4x plus 4x just becomes 0, so it cancels, and we're left with y equals 4x minus 10. Now that's pretty close to slope-intercept form. Slope-intercept form is the y equals mx plus b. So technically, you could write this as y equals 4x plus, and since we took the subtraction to an addition, we need to take the inverse of 10, which is negative 10. Now, our slope then is 4. And our y-intercept is negative 10. Now, if you can look at the equation we rewrote originally and recognize that, all right, our slope is 4, and my y-intercept is this negative 10, using that subtraction sign as your guide, that works as well. So our slope in this question was 4, and our y-intercept for this equation is negative 10. We need to pay attention to whether it's a positive 10 or a negative 10. Now, once you know how to find the slope in an equation and how to find the y-intercept in an equation, we can use that to help us graph. So we have y equals negative 3x plus 9. Well, the first step to being able to graph this is to identify the slope and y-intercept. Well, our slope is negative 3, and our y-intercept is equal to a positive 9. So on our graph, we can place a dot at the y-intercept at 9. That is the y-intercept here at 9. Now, a slope of negative 3 we can look at as negative 3 over 1. Now, remember, slope can be interpreted as rise over run. So a negative 3 rise means we are going to go down 3 for every time we run to the right 1. So we need to go from this point here at 9 with our y-intercept down 1, 2, 3 in order to go a run of 1. And we plot our new point. And again, for the next point, we can go from the new point down 3, 1, 2, 3, and run to the right 1. From here, rise of negative 3 means down 1, 2, 3, and run 1. And we might as well just go one more just to make sure. Down 1, 2, 3, and run 1. Now that's more than enough points in order to graph this. So we can draw in a line that connects our points, making sure it's as straight as possible going through all of our points. We want to draw arrows on our ends to indicate that our line keeps going forever and ever and ever. And we want to label this graph y equals negative 3x plus 9. There will be a time soon when you'll graph multiple equations on the same graphs. We want to make sure we label our lines. So to recap, use your slope of negative 3 and your y-intercept of 9 to first graph the y-intercept, and then interpret your slope of negative 3 as negative 3 over 1. So every time you go down 3, you go to the right 1. Down 3, right 1. Down 3, right 1. And now we can apply this concept into a real-world problem. A class spends $75 on ingredients and then sells cookies for $5 a dozen. The total amount earned y for x dozens can be represented by the equation y equals 5x minus 75. Now, on our x-axis, this is going to represent our dozens of cookies sold. And for our y-axis, this is going to represent our amount earned. And this amount, of course, is going to be in dollars. So we're going to graph this equation. So our first step is to identify our slope and y-intercept. Now, our y-intercept is going to equal a negative 75. Then, our slope is equal to 5. So let's start off by graphing our y-intercept at negative 75. Well, looking at our graph, it looks like each time we go down here, we have negative 50, negative 60, negative 70, negative 80, negative 90, negative 100. And negative 75 falls in between negative 70 and negative 80. So we can draw the negative 75 in right here and draw a point. And I'll write the negative 75 just to make sure we remember that. Now, on this graph, it would be a little tedious to try to graph up 5 over 1, up 5 over 1, as our slope of 5 over 1 for the rise over the run would indicate that. And we could We could go up 5 over 1. There's nothing wrong with that. It'll just take us a long time to graph. Now, notice this graph is set up for us by counting by 5s. Our runs, maybe we can count by 5s. Well, how would that work? Well, if we want to convert our 5 over 1 into something with the run of 5, how could we do that? Well, it's almost like equivalent fractions. 1 times 5 is 5, so 5 times 5 would be 25. That's an equivalent slope, just like it's an equivalent fraction. 5 over 1 is the same thing as 25 over 5. So what if we had a rise of 25 every time we had a run of 5? How would that look? Well, a rise of 25 from negative 75 would take us up to negative 50. And then we would need to run 5 dozen, or just the 5 for this question, which is right there. And from this point, what if we went up another 25? Well, that would take us to negative 25 here, and then over 5 to 10. And if we went up 25, we'd be at our x-axis, and over 5 takes us to 15. And we might as well just keep going here. Our next step up, 25 up, would be there. So we could go 25 up and 5 over to 20. And then let's finish by going up to 50, rising 25 more, and running 5 to 25. And so now we have a pretty good idea of where our graph is going to go. So we can connect our points here, drawing the arrow here. Now, part B asks us to describe what the y-intercept and slope represent. Well, let's start with the y-intercept. Now, the y-intercept of negative $75 represents, well, what? If we look at the question, it says a class spends $75 on ingredients and then sells. So they started off $75 in debt. They started off $75 short before selling anything. So this $75, a negative $75, represents the cost of the ingredients. And what about the slope? Well, our slope was 5, so the slope of $5 represents the money earned per dozen cookies sold. And that's enough for this interpretation. And that's our last example for this lesson on slope-intercept form. Good luck.